Tutor, where school is made simple. Let's go.
The origins of pi and its numeric value are a very interesting story, quite fascinating story, and probably one of my top 5 all-time favorite lessons. It starts with the idea of what is the area of a circle. And the Egyptians and later the Greeks had a very tough time trying to come up with a formula to calculate the area of a circle. They could find the area of a square. That was relatively simple. We all know that that is the side times the side, or the side squared. But we had to find this irrational multiplier that helps us find out that the area of a circle is pi r squared. Now, the Egyptians knew a very primitive version of this about 5,000 years ago. And we know this because if you take the parameter of the base of a pyramid and then divide it by its height, you'll find out that the ratio is 22/7, which is approximately the same ratio that the Greeks used a few thousand years later. So let's look at how they came to this very advanced knowledge. When we look at a circle, we know that at this time we couldn't describe exactly how to find the area, but if I tried to put it in terms of squares, I can see that there's an inner square that fits directly inside my circle, and there's an outer square that fits around it. Common sense tells us that the area of the inner square is going to be less than the area of the circle, which is in turn going to be less than the area of the outer square. So now I want to start by looking at the relationships between the circle and the inner square, and then the circle and the outer square, to see if we can use our knowledge of the area of a square in order to come to some idea about what pi may be. So starting off, I see that the square that's inside has each side labeled, but then if I use the Pythagorean theorem, I could look at the diagonal of this square, which also happens to be the diameter of the circle. And I can now look at a few things. One, I'm going to abbreviate the side as S. I'm going to abbreviate the diameter as D and the radius as R. And I know that one of the properties of a circle is that the diameter is 2 times the radius, so D equals 2R. Knowing this, I can start by applying the Pythagorean theorem, which is going to say that the side squared plus the side squared is equal to the hypotenuse squared. I also know that the D is equal to 2R, so I can substitute and find out that 2S squared equals 4R squared, or S squared equals 2R squared. Therefore, the area of the inner square is approximately 2R squared. So I know one piece of the puzzle. I know the area of the inner square in terms of the radius of the circle. Let's see what we can do with the area of the outer square. I'm going to use a similar concept and try to relate the square to the radius of the circle. And I can see that the length of the side is going to be equal to the diameter of the circle, because the circle is tangent to each of the 4 sides, meaning that its diameter is going to be equal to the side. And just like before, we're going to use some basic knowledge of circles and squares, and we're going to label the side of the square S, and we're going to say that the diameter again is equal to 2 times the radius, so that the side will be equal to the diameter, which is equal to 2R. Knowing this, I can start finding the area of the square by taking the square of both sides. S squared equals D squared, which means S squared equals 4R squared. At this point, I'm done, and I know that the area of the outer square is 4R squared. So now let's go back to our original relationship between the areas of the squares and the area of the circle. And let's look at some things. Let's substitute some values. Well, I know that the area of the inner square is 2R squared, and the area of the outer square is 4R squared. So I can say that the area of the circle is going to be between 2r squared and 4r squared. So at this point, we can say that the area of the circle is approximately 3r squared, which means that pi would be approximately 3. Now, the Egyptians used this as the starting off point in order to continue their approximations and eventually got to 22 over 7, which is 3.14 more or less, which is very close to the modern version. Just for giggles, you may be interested in knowing that the value of pi has actually been calculated out to approximately 34 million decimal places. So we have just a little bit more precision than the Egyptians did, but we still don't know the exact value of pi.